I'm going to go over a little bit of using the LC-3 tool. There are two parts to this tool. The first part here is the editor. This is where you're going to write your LC-3 assembly code, where you're going to save it, and then where you're going to assemble it, much like compiling and running in Java. And the second part of this tool is here under the simulator, and this is where you actually execute your code, and you can step through using debugging tools to see the code execute and see what's going on. So the editor is, like I said, where you're going to write your code. I'm just going to paste some code in here. One nice thing about this editor is that it does know some of the syntax, the commands, and the structure of LC3 assembly code. So you can see that it colorizes things to make it a little bit easier for the human eye to parse and follow what's going on here. So you can see that I've got an indication that I need to save this file. So you can click here to save. It's going to ask me where to save it. We can also open existing files by clicking here, navigating to where the .asm file is, and opening. This is the same file that I just saved. And then when we think it's ready, you click on Assemble, and this is going to go through and do a compilation step to check all the syntax. Any errors will be displayed down here and will require you to go up and fix problems, assemble again until you get this assembly successful message. I can switch over to the simulator and see that my code is loaded up here. Now, the very first time you run this, or the first time you run it after installing a new version or installing on a different system, there are two things you need to do so that you don't have problems in class. So click here on the gear icon, and you need to set the number view to signed and ignore privilege mode. These are features that we're not going to be using, and they produce some strange output that we really don't worry about too much in class. So in addition to these settings, which you must set, you can also switch between light mode and dark mode. Dark mode is my preference, but you can choose whichever you'd like. And now those settings are going to be remembered each time you start this up on the particular computer where you made those setting changes. Now that I've got a successfully assembled program over here in Simulate, then I can see the instructions for my program. I can switch back over here and look at them. This is what they look like when they're loaded into memory. So this is all memory locations and the particular instructions in the memory locations that the code specified. Also, there are registers over on this side. Registers are used during the execution, kind of like variables, but they're like hardware storage areas that the program is going to be using. You see that this instruction has a reference to an R0, R0. This one's R1 and R0. Here's an R2. That is referencing these general purpose registers for use in whatever these instructions are supposed to do. And of course, you can see as you execute or step over each instruction, you can see we're here about to execute this instruction. Well, that instruction didn't really change anything. It just made sure that this was a 0. Now we're going to add 2 to whatever's in R0, which is 0. Store that in R1. So we'll see R1 change now to a 2. Okay, so now there's a 2 in R2. So as you step through each of your instructions, you can see the results here in the registers. There's some other things down here that we'll talk about later as well. So when done, you can see that information has changed. We've loaded something into R2 according to this instruction, and we're now at the halt instruction, which is where the execution stops. We'll go over a lot more of what the instructions do and what the registers are used for as we continue on in class. A couple of other interesting things here on Simulate. You can see we've got a lot of buttons here. I was clicking on this one to execute each instruction one at a time. I can click here to run the entire program to completion. There are some other debugging tools such as step into and step out of, which we'll talk about when we discuss subroutines. I can also reinitialize the machine, which will wipe everything out, kind of like pressing the power button to turn it off and back on. It clears out, and effectively our simulated computer here has rebooted itself. You can see that everything is gone. So I can go back over here, I can assemble again, and it's loaded up again. So now I've loaded my program. This randomizes, which just puts random data in memory. I've not found a good use for that, but it is very interesting. And finally, if you have a program that's already been previously assembled and you don't want to bother with bringing it into the editor and assembling, then you can always load it. Let me reinitialize the machine, and then you can just load it here with the open. And in this case, it's going to open the .obj file. That is the executable version of my program, the one that it was assembled into, much like .class files when you compile your Java code, class or .jar files. So when I open this, I've loaded the program back into memory, and now I can execute it or step through it.